The reason we wrote this particular professional development was to, one more time, try to take away the barrier between elementary education, middle, and high school. So many educators think of long division as obsolete, that we don't need it anymore. And our argument is that it's essential in order for students to understand the whole number system, the real number system. And even simple things, less complex ideas perhaps, as dividing polynomials. So we want them to see it as a stepping stone to middle and high school, and that they also see it as a culmination of all that has happened before in elementary, that multiplication, addition, and subtraction are all embedded and necessary for the division algorithm. So that was one of the primary objectives of the session on a system of algorithms, so that they would see that all of them work together as a whole, building toward this long division algorithm, which is foundational for middle and high school. Why do we want to look at a system of algorithms instead of looking at each individually? There are practical reasons for that in terms of where are we putting our bundled 10 so that it doesn't confuse students or obscure what they're supposed to do with that when they're doing the division algorithm. And there's also conceptual reasons for having a system of algorithms. We all know that addition is the mama of all operations. From addition comes all else. So we start with addition, then we move into subtraction. They are composing a 10, they are decomposing a 10. They see the reciprocity of those two processes. We make a 10, we break a 10. We change 10 ones for 1 10, we change 1 10 for 10 ones. This simple idea that translates in 5th grade into place value, the movement on the place value chart of 1/10 moves you to the right on the place value chart, and then 10 times as much leads you to the left. So these are coming out in the algorithms. This idea of multiplication is right there as they're doing the addition and subtraction algorithms in grade 2. So those then in turn, the addition and subtraction algorithms, especially obviously the addition algorithm, sets the stage for the multiplication algorithm. If we have 3 24s, they already know how to add 24 and 24 and 24. That's a grade 2 standard. Now they know how to represent that. They learn how to represent that in 4th grade as 3 24s, 3 units of 24. So they say 3 24s, they start with their smallest place value. 3 times 4 ones is 12 ones. So they know they can compose 10 ones as 1 10. Or as we've talked about it, they can change 10 ones for 1 10. So the very same notation is used, and that's part of our system of algorithms, that 10 that they have composed is recorded in the exact same way. So it's very easy to see the 12-ness of 12 instead of 1 and 2, which so many children tend to think of as what that actually means. Oh, I'm going to put my 1 in the tens place. No, I've made a 10. So then we go from multiplication of a single digit by a 2-digit number into multiplication of a multiple of 10 by a 2-digit number. So where before we had 3 times 24, we might now have 30 times 24. Now this is bringing together the place value chart and movement on the place value chart and the multiplication they've already done of 3 times 24. So we see 30 times 24 is simply 10 times as much as 3 times 24. Once they've got that in place, you already have all the pieces you need in order to do 2-digit by 2-digit multiplication. It's simply taking the one partial product of single digit by 2-digit and 2-digit by 2-digit, putting them together and adding them up. So there's no additional complexity except that you're actually bringing the addition algorithm right there into multiplication. Next we go into long division in grade 4. Long division means taking the whole amount just as you do with subtraction, and we are going to do the same thing. We're going to go unit by unit. One of the things about all of the algorithms is that they are cyclic. So whatever you do, I've only been talking basically about 2-digit numbers, but that can extend out into any number of digits. So that's particularly true with division, which can go on infinitely into the decimal numbers. So once you've established that with multiplication and addition, you're always getting a definitive answer. And with subtraction, you start with a whole amount. So you're not going to get At this point, you're not going to get anything that has an extension of decimals that goes on forever. Here we go with the system of algorithms again. So now the students are really comfortable with composing and decomposing units. And so they take those, let's say we're doing 42 divided by 3. We're starting with our largest unit, which is the tens, and they're accustomed to thinking of that. They're accustomed to decomposing any number as its units and then manipulating those units within the number. So they take 42, they start with 4 tens. They say to themselves, 4 tens, if I partition that into 3 groups, then how many tens will be in each group? And they're able to do that from the simple division they learned in 3rd grade. So they have 1 10 in each group. They have a remaining 10. So they have to take that 10 and change it for 10 ones. There's the subtraction now is supporting them in their long division. So they're able to know that they can decompose a 10 from having done the subtraction algorithm earlier. They know that they have those 12 ones, and they can decompose those into 3 groups as well. In a sense, that's another application of subtraction if you want to look at it that way. They're taking the 12 ones and removing parts into 3 groups. So that's taking away 4, taking away 4, taking away 4. Then they subtract to find out if they have a remainder in the ones, 12 minus 12, and you have no ones remaining. So the subtraction is also incorporated into the division algorithm.